The second and probably most important part of the data handling process after parsing is called validation, as indeed parsing alone doesn't guarantee that the data sent by the client actually respects the API contract. So in this lesson, we're going to create our own data validation middleware using a package named Joy. Joy is a library used for validating JavaScript objects. The validation of an object with Joy is a two-step process, as first we need to construct the schema of this object using types and constraints, which is in other words its signature, and second we need to validate the schema against an arbitrary value, which in our case will be the parsed message body of an incoming request. To create a schema, we can use the top-level object method exported by the Joy module that takes as argument an object where the keys are the names of the fields we want to verify and the values are the types and constraints applied to these fields. Once the schema is defined, we can use its validate method to verify that the data matches the described format, which returns an object containing two properties. An error property, which will either contain an undefined value if the data is valid or otherwise a validation error, and a value property which will contain the type converted values of the data object, which means that the Joy package will automatically convert these values to match their declared type. For example, a Joy number will be converted into an integer and a Joy date will be converted into a date object. So let's start by installing the Joy package. Let's now create a new directory named schemas and within it 3 files named index, login, and signup that will contain the validation schemas for both the login and the signup endpoints. Let's now open up the login file, import the Joy package, and create a module that exports a schema containing an email field that is a string of characters and more specifically an email address, and a password field that is also a string of characters with a size comprised of 8 to 20 characters. Since in the case of our application the data required to log in is similar to the one required to sign up, we're simply going to copy the content of this file and paste it into the signup file. Once we've done that, we're going to use the index file to import both schemas and regroup them under a common export so that both files can later on be required at once more easily. The most trivial way of using a schema for validating the payload of incoming requests is to import it into the controller and set up the following if statement that forces the endpoint to respond with an HTTP 400 in a case of a validation error, which indicates that the server cannot process the request due to something that is perceived to be a client error. Although straightforward, this implementation unfortunately violates the dry principle since it will end up being duplicated in all the other controllers of the application. So if we now take a step back and look at our request response cycle, we notice that the message body of the request always goes first through parsing and then validation before being used as a valid data by the rest of the application. Consequently, we can streamline the validation process by creating a middleware function in charge of validating the parsed data and either break the request response cycle by performing an early return or simply pass along the request to the controller if the data checks out. So let's create a new directory named middlewares and within it a file named schema validator. Within this file, let's now import the schemas we defined in the previous step and export a function that takes as argument the name of the schema to be used and returns a middleware function. If the schema exists, we're going to invoke its validate method with the data contained in the body of the incoming request, then either break the request response lifecycle by sending an HTTP 400 indicating that the data is invalid, or forward the request to the next component in a call stack using the next function. Finally, we're going to add an else condition that returns an HTTP 500 whose sole purpose is to indicate to us developers that we tried to use a schema that doesn't exist and that we made a typo in the schema name. We can now import this middleware into the server module and initialize it right before the controllers of the login and the signup routes using the appropriate schema name. This way, every single request sent to the auth login and auth signup routes will be first intercepted by the schema validator middleware and eventually forwarded to the controllers if the payload is valid. Now that we're done with the implementation, let's test our middleware by first sending a request containing a valid email address and a valid password to the login endpoint, which should respond with an HTTP 501, which means that the request successfully passed the validation stage and reached the endpoint's controller. Let's now verify that the validation middleware breaks the request response lifecycle by responding with an HTTP 400 in the case of an invalid email address, an invalid password, or a missing field.